mad scientist. What's the matter? Oh, matter. That's right, a lot matters today, mad scientists, because we are going to be talking about all of the stuff that matters. I am talking about matter. So what is matter? Well, matter refers to anything that occupies space and has mass. That means if you can see it and you can touch it, it is matter. In other words, you really can't trust matter because it makes everything up. All of the stuff in the universe that you can see and some of the stuff that we can't even see but still takes up space and mass is called matter. It's always found in one of three states: solid, liquid, and vapor. All matter is made up of something that we call elements. Elements are things that we find on a table called the periodic table of elements. These have very precise chemical and physical properties because when we break them down, they become the cosmos's Legos that we can build back up into other substances. Some of the substances that we know of, like water, carbon dioxide, maybe even things like gold. All of those are made of elements. And each element is designated by a special chemical symbol. The most common symbol that we see on the periodic table of elements is called hydrogen. We make sure that we know we're seeing a hydrogen element by a gigantic H. But some of the four other most common elements besides hydrogen are oxygen, which is made from an O, carbon, which is made from a C, and nitrogen, which is made from an N. Together, they make up about 95% of something that you can probably see right now. No, not your TV, not your computer screen. I'm talking about yourself. 95% of the human body, mad scientists, is made up of just those four elements: oxygen, carbon, hydrogen, and nitrogen. But you're probably wondering something else about why matter matters so much. And that is, what is inside of an atom that makes them so durable and strong that we can literally make everything in the universe out of them? But hold on, mad scientists. We're going to learn right now. Matter is made up of things that are called atoms, the most basic unit of matter. If we compare all of matter to Lego bricks that create the universe around us, an atom is a one-by-one Lego brick. Any matter, regardless of its state, literally has millions and millions of atoms in it. That's a lot of Lego bricks. Atoms are so small that until recently, it was impossible to see them, even when we used the strongest microscope. Now, the word atom actually comes from a Greek word called atomos, meaning indivisible, meaning you can't divide it up. Once it gets as small as an atom, it can't get any smaller. An atom is a kind of particle that is the most basic unit of matter. But how small is it, you might ask? Well, I've got a special activity for us to try together so we can understand just how tiny those basic building blocks of the universe can truly be. I have here a super duper highway trooper piece of equipment called a piece of paper and a pair of scissors. So here's what I'm going to do, mad scientists. I'm going to cut my piece of paper in half. Not so hard, is it? I mean, we've got a pretty long, stringy piece of paper here, but you might be asking, how many times could I cut this piece of paper in half before it got too small to cut, before it was atomos or indivisible? Well, let's see. That's 2, 7. I don't think it can get much tinier than that, mad scientists. But here's something interesting that I want you to know. In order for us to cut this piece of paper down to the size of an atomos, something that's indivisible, we would have to cut it 31 times. Can you imagine how much a piece of paper would weigh or look like if it was cut 31 times? Well, I can't either. That's why, in order to understand atoms, we create models. Models like you see right here. For example, that model right there with the two big blue balloons and the one red balloon is actually a water model, H2O. Remember when I said some of the most common atoms were made of hydrogen and oxygen? Well, every time you drink water, you're drinking millions and millions and millions of atoms that are made of two waters and one hydrogen. Wait a minute. No, the hydrogen makes the water. But where does the nitrogen come in? What? Carbon? No. Guys. All right, I know there's not a pizza atom. Mad scientists. Obviously, I'm a little confused. So I tell you what, why don't we do this? Let's create our own atomic model right here in the lab. Are you ready for another activity? All right. Let's go. Oh, mad scientists. Man, am I confused. I forgot the difference between particles and molecules and atoms and matter and pepperoni pizza. It's a good thing that scientists have things that are called atomic models. Atomic models are models of things that you and I can't see with our eyes, and sometimes even have trouble seeing with microscopes. You see, the structure, or how an atom is built, really resembles an egg. It has something called a nucleus in the middle, kind of like a yolk. And it's made up of lots and lots of charged things called protons and neutrally charged neutrons. And around the nucleus are something negatively charged that we call electrons, kind of like the white part of an egg. And they rotate around and around the nucleus, kind of in orbits, sort of like a sun and other planets. Scientists have developed a model for what an atom must look like to help us understand how they work better. And the modern model of the atom teaches us that all atoms are made up of subatomic particles. Well, it means smaller than an atom, but that doesn't make sense because we know the word atom comes from the word atomos, and atomos means indivisible. Well, that's probably because when the word atom or atomos was invented by mad scientists, we didn't know that anything could be smaller than an atom. But now, let's look at a picture of a subatomic model. As you can see, right there in the middle is a nucleus. Nucleus, yes. The nucleus is made up of protons and neutrons, kind of like the yolk of an egg, and then that means those electrons that you see on those ringy-dingy stringies are spinning in the orbits around the outside of a nucleus, kind of like a moon around the planet Earth. Now, what are protons? Well, protons are those things in the middle along with the neutrons. They're positively charged. They're located in the center of the atom, and they, or at least we know the hydrogen atom, is unique in that it only has a single proton and no neutron in its nucleus. You see, mad scientists, one of the reasons why things like carbon, oxygen, nitrogen, and hydrogen make up 95% of things like the human body is because they're very, very simple atoms. That makes them very, very elastic, which means we can build all sorts of things with them, including your hair, your fingernails. Now, as I said, the electron is the negatively charged particle that spins around the outside of the nucleus. Electrons are attracted to the nucleus by the positive charge of the protons. Just like Small objects, such as moons, are attracted to larger objects, such as planets and suns. Electrons are much, much smaller than neutrons and protons. How subatomic? About 1,800 times smaller. I don't know if we will ever invent a pair of glasses that could see electrons. But did you know, mad scientists, that we actually have developed something called an electron microscope? Now, finally, the neutron. It doesn't have any charge at all. The number of neutrons that each atom has will generally just affect how big or the mass of an atom. But it also affects something called its radioactivity. In other words, the more neutrons that an atom has, the potentially more dangerous it could be to you and I and all of our 95% atoms that are made up in our human body. So, come back to me from the model for a second, mad scientists. I've got some super duper shield trooper equipment called pipe cleaners and pom-poms here. And I'm going to try to make an atom. Now, for this activity, mad scientists, if you want to join along, just like me, you're going to need some pom-poms and some pipe cleaners. And I'm going to start by trying to build our nucleus. And that means that I am going to attach some neutrons and protons to the middle. Now, I am only going to put one orange neutron on my nucleus. Well, why would I do that, mad scientist? Well, obviously because I don't want my neutron to be too radioactive. Now what do I do, mad scientists? Well, after that, I'm going to make one of those spheres for our electrons to go around on. Now that I've attached my nucleus, mad scientists, I can unbind that electron coil, and I'll put one electron on each of my coils. I think that I'm not going to build a very complicated atom, so I'll probably only put 2 electrons, which means I'll need 2 coils. Because I don't want my atom to have too powerful of a charge. So that's 1. There's 2. See, mad scientists? I created my own atomic model. So even if I ever get confused in the difference between water, hydrogen, or pepperoni pizza, I can always look back at this model to remember that there are subatomic substances or particles that even make up the seemingly indivisible atoms that comprise all the matter in the universe. But that yields a really important question, mad scientists. What is a molecule? How do we know we're looking at one? And can we see evidence of molecules even with our eyes without using a microscope? Well, that's a great question, mad scientists. And if I scratch my head so hard that it files the fingernails off of my fingers, I'll bet we can find an answer. But let's find out.